be talking about today is the Born Haber Cycle. And this is going to be a quick recap of how the Born Haber Cycle works. So we're going to go through the steps. And one thing I want to make sure that you have memorized is Stan smiles as I eat lettuce, he. Because if you have that down, it's going to take you right through the cycle. And you can basically add up all of your numbers and the entire cycle equals 0. Okay? What we're basically trying to calculate when we do this cycle, though, is something called lattice energy. And lattice energy, if you remember, is the energy. It is always going to be energy absorbed or energy released. It's always energy absorbed, okay? It always requires energy. It's the energy required to, I don't know if you remember this, it's the energy required to break an ionic solid into gaseous ions. Awesome, okay? So what you're doing is you're taking NaCl, for example, and you're breaking it up into its ions. And so what this cycle is going to do is it's actually going to give us the negative of the lattice energy. But once we get that, we can actually solve for the lattice energy. So I'll show you how that works. Okay? And the whole cycle ends up equaling 0. So we're going to basically go through this entire cycle, and then we'll set it all equal to 0. So I'm going to go to a blank chart on here, okay? If you have a blank piece of paper, you can just have this out, or you can just use the one that's there. And first thing we're going to do is we're going to write, everybody repeat after me, Stan smiles as I eat lettuce, he. Here we go. Stan smiles as I eat lettuce, he. Okay, so let's talk about what everything stands for in a minute. So this first line right here, this is going to be our starting point, and this is going to be our Stan right here, okay? Then over here, I'm just going to write smiles. Now in between, that number 2 is going to be as. Number 3 over here, this whole part here is going to be I. Over on this side is going to be my eat. As I eat what? Lettuce. And then over on the other side down here is going to be he. What does everything stand for? Okay. Stan means put your elements in their standard states. Smiles is what? Sublimes. This is sublimation, which subliming is changing from a solid to what? A gas. Awesome. Okay, so that's going to be sublimes. Stan smiles as. What happens there? Atomization. What happens in atomization is, if you have a diatomic molecule, for example, you're going to atomize. You're going to create single atoms. So instead of being Cl2, it would be 2Cl. Maybe it's 1/2 Cl2. If it were 1/2 Cl2, when you atomize it, what does that equal? Just 1 Cl atom. Okay, so you're atomizing it. You're taking something that's diatomic and you're turning it into single atoms. I, what is the I for? Ionization energy, that's an easy one. Oops, ionization energy. Eat, what is that for? Electron affinity. So that's electron affinity. And remember, that's the energy that is associated. It can be positive or negative. It's the energy associated with gaining an electron, okay? With the gaining of an electron. And the last thing is lattice, which we're going to say is lattice energy. So this is lattice energy. But it's the negative of the lattice energy, okay? And so lattice energy is typically written as delta H and then LE for lattice energy. Okay? So we're going to start at the beginning, and the first thing I'm going to do is I'm going to write what substance I have down here, okay? And the substance that we're going to use is, let's use calcium fluoride, CaF2. Okay, we're going to use calcium fluoride, CaF2. So the first thing we're going to do is we're going to put the elements in their standard states. What is calcium in its standard state?
Solid.
Ca solid plus. And now, what is fluorine in its standard state? F2 gas. Now, it is balanced. If this were CaF, okay, like you would have CaS, for example, if this were CaF, then you would be saying 1/2 F2, okay, because there would only be one F. So you want to make sure that it's balanced, all right, which that is balanced. So that's step number 1. That's the very first thing you're going to do is put them in their standard states. Next thing. We're going to sublime it. What happens in sublimation? Solid turns to gas. So I'm going to have this calcium turning into a gas, and nothing is going to happen to my fluorine. So plus F2 gas, and here is my change right here. We're going to take a look at what chart? What chart's going to give us this value? Thermo. We're going to take a look at our thermo chart. And we're going to come down to calcium. Now, you all know that calcium as a solid is 0, so we don't have to look at that. We're going to look at calcium as a gas. And calcium as a gas is 179.3. So let's come back to this. And we've got, this is the product now, this is the reactant. So we're doing 179.3 minus 0. Remember, products minus reactants. So 179.3 minus 0 is just 179.3. So in here, I'm just going to write 1. Let me switch my colors now. And let's use this color. I'm going to do 179.3 kilojoules per mole. Okay, that's in kilojoules per mole. Next step. So now what do I need to do? Once I have, I've already done my subliming, now I'm going to atomize. So what happens in atomization?
2F.
Perfect, plus 2F. Now my calcium's still a gas, so I'm not going to change that. It's going to be calcium as a gas. Sorry, will you pause for 1 second, actually? Okay, so now our calcium as a gas is going to stay the same. So I've got Ca as a gas plus, but now it's atomization, so F2 instead is going to be 2F gas. Okay, so now this is my change right here, and I need to find out the value. Product minus reactant. Well, F2 gas, where are we going? Where are we looking at this? Thermo chart. Okay. So I know that fluorine, F2 gas, is definitely going to be, I need to go to the next page, is going to be 0. So I'm really just looking for F gas. So let's see, oh, it was on this page. So let's find fluorine. And what do you know that F gas says? 80. And F2 gas is 0. Okay. But it's 2F. So you have to do 2 times 80 minus 0. So don't forget, you always multiply by the coefficient. So that means that this value is 160. So now I've got 160 kilojoules per mole. All right, next step. Okay, what do I do next? After I atomize, now what happens? What happens in ionization?
Take an electron away.
Remove the electron. Who loses the electron? The metals. The metals are going to lose. Remember, the non-metals are going to gain. So now I've got my metal losing the electrons. So instead of calcium being calcium gas, well, let's just write it first. So I've got calcium gas. It's going to end up being calcium gas plus 2 electrons, but I'm going to show it as an ion now, okay? So calcium is going to lose its 2 electrons and become Ca2 plus gas plus 2 electrons plus, did my fluorine change?
No.
Nope, so that's still 2F gas. So what happens here is that right there, and this is called the ionization energy. I'm not looking at my thermo chart now, because if you start looking for this on your thermo chart, you're not going to find it. What are we doing? We're going to look at our ionization chart, that's right here, and we're going to find calcium on there. So what happens when calcium loses an electron? Well, the first electron is right there. So do I multiply it by 2? No, what do? You add the 2 together. Okay, we're going to add the 2 together. 589.8 plus 1145.4. So it's 589.8 and 1145.4. And if you add these together, you get 1735.2, again, kilojoules per mole. Okay, so now we have our step where it was ionized, meaning the electrons came off. Now what's going to happen to the electrons? They're going to get gained by the nonmetal. So now the nonmetal is going to gain those electrons. So this is going to be calcium 2 plus, but these 2 electrons are going to add on to the fluorine. So I'm going to get Ca2 plus, instead of having those electrons there, it's going to be 2F what? Minus. So one of the electrons, and now you're probably wondering, yeah, but there are 2 electrons. So how does this work?
Times 2.
Yeah, there are 2 fluorines. So each one gets 1. So it's not 2F minus 2, it's 2F minus, okay, the charge of fluorine. So now what just happened is fluorine gained 2 electrons. So let's check to see what electron affinity, what the values are. So on the back of the ionization chart is an electron affinity chart. And who's gaining the electron? Fluorine. So I'm going to find fluorine, and it says negative 328. But how many fluorines are gaining 1 electron? 2 of them. So we actually have to multiply it by 2. So, I'm sorry, was it negative 328? Okay. So it's negative 328 times 2, which is going to give us a negative 656 kilojoules per mole. Okay. Then comes our lattice energy. All right. But we don't know. This is X. This is what we're looking for. We're looking for that. Okay, but the negative of it. So now we're going to come right back here. And what is he? Heat of formation. Delta HF. So we're going to take a look at our chart, at our thermal chart, and we're going to find CAF2. So let's go to the calcium section, which is right here, and you're going to find CAF2 right here. And there's our value, negative 1219.6, but anybody remember? You have to flip the sign, okay? It's the reverse of it. So this is actually going to be positive 1219.6. So let's come back, and it's a positive 1219.6 kilojoules per mole. This is the delta HF of CAF2, but it's the reverse of it, okay? It's the negative of the delta HF, of the heat of formation of it, because we're going the opposite direction, okay? So if it were positive, make it negative. If it's negative, make it positive. All right, now, remember that this whole thing equals 0, okay? But if this is negative, if it's negative delta H and we're solving for X, so if I had some number 2 plus 3 plus 6 plus 5 plus negative X all equal to 0, what can I do to solve for X? Just add X to the other side, right? And just say that this is all equal to X instead. Do you agree? Okay, so all we're going to do is we're going to go right around our circle and we're just going to add these numbers up and see what we get, and that should equal X. Go for it. So go ahead and add up all the numbers that we just wrote. So I've got 179.3 plus 160 plus 1735.2 plus negative 656 plus 1219.6. And please tell me what you get for your lattice energy of CAF2. Delta H lattice energy of CAF2 equals what? And your number needs to be big and very large and positive. Are you getting something in the 2,000 range?
Yeah.
What are you getting? 26, 38, something like that? Perfect. You should get something around 2638 kilojoules per mole. If not, just make sure that you check your calculations because maybe you have one sign that's wrong. Okay? And that's basically it for the Born Haber cycle. That's it.